Let few more students join, then I will start. Okay. Okay. Good morning, everyone. I hope my voice is audible to everyone. So today we will discuss about linear regression with Excel. So this is the portion of data analysis function using Excel. So till now, Pankita madam and Surajit sir have discussed many functions in Excel. You have learned many part. I hope my voice is audible. Just confirm anyone.
Yes, sir.
Okay. So this portion, this part today I will be discussing is based on the experimental values that we obtain in lab and the analysis of data that we carry with Excel. Okay. We will see some examples of lab of solid mechanics lab and how the datas are that are obtained from experimental results are analyzed, and using the built-in function that is present in Excel, we will do the analysis, and we will see the result, we will plot it, and it will be visualized that how the data has been analyzed. So this function that today we will discuss, that is linear regression, is the best option for giving the relationship between a theoretical result from the experimental result. So basically, there are many methods that could be discussed. One is your linear regression, one is your polynomial regression, and one is your interpolation regression. So we will see how these so the linear regression from this the function, we will see that how the data that is obtained from the lab we have to plot, and sometimes we have to bring a straight line out of the different points that we have obtained from the data in lab. But in practice in lab, that we have seen that the points we try to connect may not fit in a straight line, and mostly you find a haphazard line or curved portion which is basically not linear. But theoretically we want a linear line. So to obtain this straight line that will fit the most closely points that are present is done by using the application of linear regression. So suppose we have a point that we have to fit in a straight line for equation y is equal to x plus b, where a is the slope of the line and b is the intersection of the straight line in the y-axis. Then by using the method of least square method of this linear regression series, you can fit the point, the n number of point in the particular data plot of x and y-axis. Okay, so this actually gives a linear using this linear regression we can have a linear relationship between these two variables. So when the so if you see, there is another parameter that can be useful for determining the extent of the straight line that fits with accuracy into the plot. So see the chart here, x and y axis, where the straight line equation formed y is equal to x plus b, and there is a deviation that present, that if you denote in terms of capital E, then it is actually the sum of the square between the distance, and that distance is between data point and the fitted point, that is denoted by small e. So this capital E deviation is summation of square of small e, that is x plus b minus y square. Okay, this is the theoretical part. So we will see how this is applied using Excel. There is another term called r square value. This is r square, please ignore the square value. Please consider the square value. This is not R2, this is R square. So this R square value, we will also see how it is obtained with linear regression in Excel. And this actually gives the extent of how much the regression that we have obtained is close enough to the straight line. It varies from 0 to 1. So the least when it fits the straight line is 0, and the more it fits the straight line, the data that are present, different points that we plot that are present, the more it is accurate, the more it is closer to 1. So when the R square value is 0.98, we say it is most accurate. And when the value is 0.75 or 0.63, then we will say it is least fitting the straight line. So using this linear regression in Excel, we have to follow the trend function. To obtain the regression in Excel, we have to use the trend function. Okay, and this is done by using trend line. Trend line. The trend line. Using this trend line, we will see the regression line and the relationship between the x and y coordinate system. Okay, the steps that we have to follow, I will show. I will also show this. Just you can just write it down. That after plotting, after we have obtained the required plot, then we have to right click on the mouse pointer where our point data is there in the graph, and from there we will get the menu box where the trend line option will be there. We have to add it to the display format, and we have to select the requisite trend line format for linear regression. Okay, you may not be able to understand right now, but when we will do it, then you will get to know. So let me show you. So let me show you an example uh, of a soil mechanics lab, that is soil shear strength. So for direct shear strength that we obtained from lab test, uh, this is the figure that the you obtain from the direct shear stress, normal stress versus shear stress. So from this, we know that the the data that is generated, the points that we get from the normal shear stress and the direct shear stress, normal shear stress versus the shear strength curve, we don't get a straight line. Okay, the failure envelope that we see is not showing a straight line because the points are not doesn't fit in a straight line. But in theory, we need to fit this data in a straight line. So that is done by using regression. We will see how it is done. Okay, so this is the failure envelope. You can see the from the lab test, the plot between shear stress versus normal stress. So using this linear regression, we will obtain the shear strength parameter. We will see how the shear strength parameter, cohesion, and shear angle of the soil mass is obtained. Okay, so in this direct shear test, we know that the straight line equation that we get is in terms of the equation that is tau is equal to c plus sigma tan phi. So the shear strength is equal to cohesion plus normal stress multiplied by shear angle, all Fourier slope envelope. So if we obtain the equation of line, we will obtain the value of cohesion and the value of shear angle, that is failure envelope. And using this trend line, we will obtain these values of cohesion and shear angle. So to do this, what we have to choose first, you have to prepare the table, and after from the table we will prepare the plot. We will obtain the plot, and that plot will be expressed. That using that plot, we will apply the function trend line, and from there we will get a. If you open the format trend line, this is the picture that is showing. So there are many options that are exponential, linear, logarithmic, polynomial, power, etc. So we will choose the linear. So by default, linear will be chosen, and from there, see that at the bottom of the penta, penta, mouse টা যদি হয় না এটা শো করবে আচ্ছা আচ্ছা হ্যাঁ 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 so from this trend line option, exponential, linear, logarithmic, polynomial, power, these are options. So by default we will choose the linear option will be there. So for different application we will have different functions. So at the bottom you will see display r square value on the chart is given. So from here we will obtain the r square value, and we will be able to understand the degree of extent of how much the data that are obtained are close to that fits to the straight line. So these are the steps that you must know. That first we have to prepare the plot from the chart given, and after that from the display chart menu box we have to obtain the add trend line, and from that we have to format trend line dialog box here and choose the linear option. There is next step is to do the backward intercept y axis. I will show how it is done. And the backward, this is the backward intercept y axis. The since the data obtained will be after a certain value of normal stress. So the backward function is required to obtain a straight line, and after that we will see the display equation on the chart. By selecting this, we will be able to obtain the equation of the straight line, and from the equation of straight line, as you can see, this is the equation of straight line. Y is equal to, this is the example of equation of straight line here given. Y is equal to 0.437x plus 0.364. So from here you can see that is equal to y is equal to x plus b. So here 0.364 is the cohesion value, and phi and tan phi is your tan phi value is 0.43. So from there, if you do the inverse of tan, then we'll obtain the value of phi from the failure envelope. Okay, all of you have understood this, or should I repeat any part? Okay, I'm just again showing this slide once again briefly. So I'm just telling uh, the steps one by one. First, we have to obtain from the data that are obtained from the lab test. We will prepare the chart from the datas, that is normal shear stress and normal stress and shear stress, and after that we will plot it. After plotting, we will after plotting we will go to trend line. We select the function trend line, and after selecting the trend line function, we will select the linear and display the r square value, and we will also select the display chart equation, and after that we will obtain the we will obtain the values of the equation of straight line we will obtain, and from there we can get the cohesion value and as well as shear angle value. Okay, so let me show you how it is done. Okay, I will show you the example how the linear regression is applied using example. I will share the screen. So this is the test result that we have obtained from direct shear stress. We we have applied a direct shear force of in three steps, three samples we have taken. Three times we have done using one using 50 kilopascal, another direct stress 100 kilopascal, and another 200 kilopascal. So from lab test, we have obtained the shear force value and the displacement values are obtained. Okay, these two values are obtained from the test result. So suppose we have to first let me show you the plot how a plot is done. So by giving the stress strain curve of this value, I will show how the plotting is done. So first, before that, let me bring the stresses. So how you can obtain the stress obtained will be your force shear force versus by area shear force by area. So suppose area of the sample is 0.003 meter square, and to obtain the shear stress we have to divide the shear force with area. So let me give the formula, all of you know how to do it. Equals to shear force value divided by area 0.003 and multiplied by 1000 obtained in millimeter to obtained meters, and just double click here and we will obtain the forward. এই ভ্যালুগুলো যেরকম আছে এই এই রেঞ্জে আছে 20 মাল্টিপ্লিকেশন টেবিল এই ভ্যালুগুলো আছে ইকুয়েশনে হ্যাঁ ইন্টু 1000 একটা ব্র্যাকেট দেবো ফোর্স বাই এরিয়া ঠিক আছে ফোর্স বাই এরিয়াই হবে এরিয়া সেল নেই এরিয়াটা আমি পয়েন্ট জিরো পেয়ে যাই পয়েন্ট জিরো জিরো স্কোয়ার মিটার স্কোয়ার মিলিমিটার ওই ওই জন্য 1000 মাল্টিপ্লাই করেছি হ্যাঁ হ্যাঁ ডিভাইড না আমি তো মাল্টিপ্লাই করলাম হ্যাঁ ঠিক আছে হ্যাঁ হ্যাঁ ঠিক বলেছেন ডিভাইড হবে ডিভাইড হবে Okay, so the shear stress that we obtained, this is the value of the shear stress. So the shear force, that is shear force by area and divided by 1000 to obtain in meters. Similarly, the displacement that we want is in meter. So we have to divide it by 1000. So how we will do it equals to this value divided by 1000. Just double click here and we'll obtain the displacement value in meters. Similarly, for this sample 100 kPa, we will obtain the shear stress force by area divided by 1000 and we have to obtain the displacement in meters. We want the displacement in meters. So equals to displacement divided by 1000. Double click to obtain the displacement. Okay, I hope all of you are following me. No problem. If you have any doubt, you can ask, you can interrupt me. So shear stress, what will be the value? Force. So equals to shear force divided by area point zero 0.003 divided by 1000. Double click and you will get the values for the whole cell. Okay, so we have obtained the and displacement also required in meters. So displacement equals to displacement divided by 1000. Double click and we will get the displacement 12. Okay, so now I will show you how to do the plotting. So for plotting, plotting to obtain the shear stress strain curve, if I want, then stress we have obtained. We want this table and this table. displacement. This is the strain. So to obtain the stress strain curve, we will go to insert. If you have the Excel file open in your system anywhere, you can also try with me. You can have a random value there, and you can practice there also. So insert, we will choose the scatter plot. There are many plots for the column, line, pie, bar, area, scatter. So let me choose scatter plot. And in scatter, there are also many different types of plots that we can obtain. So we will choose the scatter plot with smooth lines and marker. Actually, the whole cell was selected, so that's why this came. So let me again show you. Insert, scatter. You can ask. Select point them. So this is so we have selected the scatter plot. Okay, blank plot. So let me plot it at a certain distance so that it doesn't get hide the data. So after that, the chart area, in this chart area, you have to right click. Okay, let me again show you how it is obtained. Let me just delete it. So actually earlier the somewhere it was selected, so that's why that chart came. So go to insert, scatter plot, scatter with smooth line and markers. We can later on change the layout of the chart. It doesn't matter whatever you choose. So we will have it in a certain portion area where it won't hide the datas. And after that, you have to select the data. You have to right click. You have to right click and select. Go to select data. So after going to select data, this select data source box will pop, and you have to add. You can give a series name, whatever you like. One. Then there is series X value. So X value will be your displacement. So displacement value, we will choose this box, and we will select the portion of the data that we have to choose for plot. That is displacement in meters I have chosen. Then again click here, and after that it will come here. It will come here, and next we have to choose the series Y values, the Y plot data. So click again here, and the shear stress value we will choose. So after it is chosen, we have to click here, and all the datas are have got installed, and after that we have to click OK. You know, so I can open up this project. Okay, so see the first plot that we have obtained, the stress strain curve that we have obtained. uh, this is how the nature of stress strain curve from direct shear test of soil. You can also change the chart type here. There are options available. You can include the chart axis and all. We will see this is the displacement. You can write here this displacement and the shear stress. Next, similarly, we have to, if you have to compare the different values that are obtained uh, by the different using the different direct stress. Suppose for you have to compare the stress strain curve of 50 kPa versus the 100 kPa value. Then how will we do? Again, we have to go to the chart, select the chart area, and right click on it. Go to select data. We have to add another plot. So add, name it series 2, that is 200 kPa. Again, we have to get the x value for the plot. Click here. X is your displacement in meters for 200 for 100 kPa. Select here to add the datas. Then go for y-axis. Similarly, go here and that is shear stress for 100 kPa. Select the data. So whole when the whole box is selected, you will see this type of indications that it is selected, and after that, click here and OK. Now see how is the nature of stress strain curve for your 100 kPa direct stress. Okay. Now again you have to compare it with 200 kPa value. Similarly, we have to go to the chart area, right click, select data, add series name 3 suppose for 200 kPa. X value is the displacement in meter. Okay, added. Then go to the Y value, select Y is the shear stress selected for 200 kPa, add, then OK. So once you OK, now see the chart. See, now you can easily compare between 50 kPa, 100 kPa, and 200 kPa. So this is the nature of stress strain curve that is obtained from the direct shear test. Okay, so this is how the plotting is done. Okay, now we have to come to the uh, linear regression value. So for that we have to plot the normal stress versus shear failure value. So the shear stress at failure will be the the maximum value of the shear stress that we obtain. Okay, so suppose for the so we have three normal stresses value: 50 kPa, 100 kPa, and 200 kPa. For them, we have to choose the maximum value of shear stress for each. So we can obtain this by using the function max. So let me choose a column equals to max. Max is obtained. Now choose the column that you want the maximum value shear stress for 50 kPa you want. We have chosen. Close the parenthesis. Enter. So we can obtain the shear stress value at failure. The maximum value of the shear stress we have obtained is 29.67. Okay. Similarly, for 100 kPa direct stress, we can obtain the maximum shear stress value. How we will do it? Similarly, we will go to the function max equals to max. We have to select the data and the maximum value is 56.67. Similarly, for 200 kPa, we will obtain the maximum value from the data that is equals to function max. Select the data range, set of data, enter, and we will obtain the maximum shear stress value. So we have obtained the maximum shear stress and normal shear stress value, as you can see. Now here we will plot it again, and we will from here we will see the whether the the values that are obtained are in a straight line or not. So similarly, we have to again Go to the plot, insert, choose scatter, linear. Sorry, actually it was selected. Actually, if any portion is of the Excel, any cell is selected, then it will choose the data automatically. So you have to first select any blank cell, then go to insert, select data. So yes, we have obtained the blank uh, chart area. Similarly, after that, you have to go to the right click and select data. After selecting data, you have to add. Okay, series name. Suppose you have given direct shear stress. X normal shear stress and Y value shear stress at failure. So yes, we have obtained the for using this three value we have obtained the we have you can see the plot. See the line is not perfectly straight. If you see the data, the plots that are there doesn't fit in a straight line. Okay, so what function we have to use? We have to use trend line to uh, get the straight line, theoretical straight line that we have to obtain from the test value. So what for that what we have to do? We have to right click on the chart area. We have to go to format chart area. Sorry, uh, in the plot, if you select the data, if you select the the line that we have obtained, if you select the data area, the point, right click on that, and the option you will find is add trend line. Okay, in the plot you have to select. Okay, in the plot you have to select any data, and you have to right click to obtain the this dialog box where add trend line is there. So after add trend line, this format trend line box will pop. Okay, so by default we have linear option is there in the trend line. So we want the equation of the straight line. So display equation straight line, and we also want the r square value. So after you can check the box, you can and since the straight line is not continuous and we want the intercept in the y-axis, so we will do the backward periods. Suppose we take 50 and we will close it. So now you can see this is the straight line we have obtained. This is the equation of the line that we have obtained. This is the equation of straight line, and this is the r square value which is closely fitting to the straight line. That is why it is close to 1, that is 0.999. Okay, and you can see the black line that is showing the straight line, and here is the intercept. That is the you are seeing the linear DST. So this is how we obtain the linear straight line for our intercept. And with this equation, as I have told, we have from here we can obtain the c value and phi value. Okay, understood everyone? So as I have told, what is the c value? This is the equation of straight line y is equal to ax plus b. So if you see this in terms of y is equal to x plus b, y is equal to x plus b. So b is your 5.5. 5.5 A, A is our value of C that we have obtained, and A, that is your tan phi, value of tan phi is your 0.499. Okay, so this is how you can easily obtain the value of C and tan phi using this trend line function and using this uh, line equation. Okay, you can add title axis here. Uh, the normal stress versus shear stress you can write here, and this chart you can use for your project, for your upcoming final year project. This type of this is very useful for you if you do any project for writing any theoretical for any uh, experimental work, for writing any project or paper, technical paper. This application will be useful for obtaining the straight line and obtaining the value of C and tan phi. Okay, anyone have any doubt? If you have any problem, you can come up. Okay, let me quickly show you the similar way how using this linear regression trend line we can use in plotting, obtaining the plots of liquid limit test. So using the example of liquid limit test, I will show you how the application of logarithmic regression we can use here. So till now we have seen linear regression. We can see the we have seen the straight line plot. So similarly, instead of here in the straight line equation, we will only change is that instead of ax, it is a ln x. That is log in terms of log. The x intercept is there with the y. The straight equation is y is equal to a ln x b, where a and b are constant. So this logarithmic regression application is your liquid limit test. So we know that the plot that is obtained in the liquid limit test is your number of blows that are given versus in the secondary apparatus versus the water content, and after the plot we can get the we will just in the x-axis we know that the number of blows is in the log term. So here we have to fit that in a semi-log, since this is a semi-log curve. So we will see how it is done. Okay, so this is the uh, data that are obtained from in the lab, the water content and the number of for the number of blows that we have obtained. So we will plot it. So for that you have to select a blank cell, then go to insert, select scatter move smooth marker. So blank chart area is obtained. Select right click, then click right click, then select data, add. This is your liquid limit test. select x value, that is number of blows, and enter. Then select y value, that is water content in percentage, enter. Okay, and we will obtain the plot. See, this plot is not in a straight line, as you can see. So similarly, we have to go for trend line. The logarithmic regression we will follow. So for that, what we have to do, you have to choose the plot data area, and here you have to right click and add trend line. So after clicking add trend line, this dialog box will open. So earlier we have used linear trend line, now we will use logarithmic trend line. So after using logarithmic trend line, you want to display the equation of chart, and you also want to display the R square value. And so let me close it. So you can see that the straight line is obtained, but before that we have to choose the logarithmic. In the x-axis we have to choose the we have to choose the logarithmic scale. Yes, we have to choose the logarithmic scale. In the x-axis, the data area, you go to the you click right click, uh, format axis. You go to format axis, and after that, the format axis box will prompt, and here you have to select the logarithmic scale. So after clicking the logarithmic scale, then the logarithmic scale will obtain. Then you go for the regression, add trend line, logarithmic, display chart R value, and close. So this is the regression that is followed in the see the deviation of the values, test data values that are obtained, and the straight line, that is theoretical straight line, that is obtained. So this is the equation of straight line, and the R square value is 0.998. So this is the deviation of the test data value from the straight line. Okay. Okay, this much for today. If you have any doubt, you can ask. All of you write your name and roll number in the chat box for today's attendance. All of you write your name and roll number, those who have not written, for today's attendance. If you have any doubt, you can ask.